This is a continuation of a video I did on this Sprague model TCA-1 capacitor analyzer, and in that video it seemed like this thing wasn't working properly, so started this second video to do a little troubleshooting on this unit and see if we can figure out what might be up with this. Alright, so I've got it tilted up on its side, and usually the first place to start with problems is the power supply. So what we're going to do is we're going to check out power supply voltages. And this area right here is the filter electrolytic for the unit with the 450 volt capacitors in it. This over here is the rectifier tube from the transformer. So what we're going to start with is just take a look at what we have here for AC, DC, and DC voltages, and then AC. If there's a lot of AC, that will clue us in that the filter electrolytic might be bad. So what I'm going to do is, I got this already plugged in, I got my meter here. We're going to turn this on and I'll let it go for a little bit to warm up. And as before, there's quite a bit of hum on this, and that's just unusual to me. This is not a radio, it has no speaker, so any humming has got to be most likely from these transformers. In the prior video, at the end of the video, after I turned the thing off, those transformers were a lot warmer than I would have expected. I mean, you expect them to be warm, but these were almost hot, and that doesn't seem right. So I'm going to let this sit here for a few moments, and we have our green. I think is the last thing we were doing with this is trying to see if the capacitance meter worked. Alright, I do have my my DMM here, and let's see, how am I going to do this one-handed? Probably not very well, so let me break here for a moment, and I am going to connect up some gator clips so that I can do some probing one-handed on that main filter cap. Be right back. Alright, we're back, and what I've done here is I've hooked a gator clip up to the negative post of the big filter cap, which apparently is isolated from the chassis, and we'll look at the schematic in a while and we'll see how that is. So there's a two-section filter cap, and this resistor right here is between the two sections of the cap. So I'm looking directly across the filter cap. Now remember, the caps in our prior video were rated at 450 volts, so I am not sure what I'm expecting to see here, but it's going to be a fairly high voltage. So let's take a look at the DC level, and oh my goodness, we do have 452 volts across that one section of the cap. A 450 volt cap, you'd expect there to be some design margins, so I wouldn't expect there to be quite this much voltage. Alright, let's look at the other section, and we have looks like a 1K resistor there. And that one we have 426 volts, which, yeah, there would be a drop across that resistor. So from this hum standpoint, let's change this meter to reading AC voltage. Alright, and if we look again at the side of the cap that had the 450 volts, oh my goodness, I heard it beeping, and it was shooting up over 1,000 volts there for a moment, and wow. I'm not sure what's happening with this. This is some pretty interesting behavior. Why would the AC voltage be going over 1,000 volts, then declining, and then jumping up over 1,000 volts again? That's very odd and concerning. On the other side of that cap, we have obviously similar behavior with a little bit lower voltage. So I wouldn't consider this normal. That seems quite unusual. Kind of dangerous and scary, actually. All right. What I'm going to do, I don't know what the nature of this is. The meter is probably responding to maybe some spiky type voltages, and then that's what's happening. So what I'm going to do is I'm going to get a scope on this and just see what's there, because it doesn't seem like that is 60 hertz hum as you'd expect. Alright, going to take me a moment to get a proper scope set up, because this is a high enough voltage. A normal scope probe is really not appropriate. I need like a 100x high voltage probe, and I need to dig around for that, and we'll come back. Alright, I've got a 100x high voltage probe connected to this THS-720 portable scope, which has isolated inputs. And one of the reasons I did that is this filter cap is not common to the chassis ground, which means it's not earth grounded through the free prong cord. And so I'm floating, so the scope is actually floated up off the ground of that filter cap. So then what I did is I've got, let me get a insulated device here. I have this ground clip on the ground of the cap, and this wire here goes over to here, and I have my DMM ground here, and I have the scope probe ground here. So we're going to look at the voltage again across that filter cap, and see what, as you recall, if I take this and I touch it to that point there, it says 454 volts DC. Fine. If I change this to AC mode and probe over here, it's jumping all kinds of crazy high voltage numbers up and down, over 1,000 volts. And that's the reason why I wanted to get this scope probe on here, to see what we can see. So here we are looking at, let me see if I can get some of the light glare out of here. So I have the scope displaying min and max, and we got a min of 470 and a max of like 500-ish. Doesn't seem to really be anything there. If I go to menu and we change the coupling to AC, and let's move that up. Alright, and then let's make this more sensitive. This will show the ripple just due to the filter caps. So I think there's something else going on here. Let's see here. Where's our trigger level? Trigger level. Okay. So we don't, hopefully you can see that. The ripple voltage here is only maybe 5 volts peak to peak on 450, so it's not crazy high. And that's on the kind of the rectifier side. If we go on the other side of the 1K resistor here, it should be over here. Let's see here, is that stuck on there? Yep. So over here we have basically no ripple at all, or very minimal amount of ripple, which is what you'd expect after an RC section. So going back on the other side, whoops, I see my ground popped off. That's kind of scary because, stay. Okay, so we have that, but the meter freaks out on it, and I'm wondering, is there some kind of a spiky waveform that I can't see here that's sitting on top of that? So what we're going to do is see if we can find that. I want to go back to, I think, the DC coupling. All right, and let's see here. All right. So if there is something there, I'm going to trigger on, let's go to normal triggering. Yeah. And then see if there's something to be seen here. It's really curious that the meter freaks out on this, and yet I'm not seeing, or at least the scope isn't able to pick up anything like a spike or something that's riding on top of this. I don't get anything here. Interesting. I don't know what's magical about the voltage there that would cause this meter to have a problem with the AC content riding on, 450 volts or something. Maybe it's a problem with the meter. All right. So I'm not getting any triggering here on a spike waveform. On the other hand, I still don't like this voltage being so high that that we have, essentially the cap rated voltage, or very close to the rated capacitor voltage at no margin. That just doesn't seem right to me. Whoa, be careful. What, did I accidentally touch something? Apparently. You got to be careful when you got these high voltages. If I was at my lab at work, I wouldn't be really permitted to do this. This is violating lab rules. You would have to make your meter connections and then put a plexiglass cover over your circuit before applying power. You can't be probing around in live circuits at these high voltages in my lab at work. So definitely got to be careful. The old rule about when you're working on tube circuits, one hand in your pocket, so you only have one hand in, and you can't get a high voltage short between two hands across your chest and kill yourself. That certainly applies. All right, so I'm going to check a few other things. I'll be back in a moment. All right, before going any further, it's worth taking a look at the schematic for this capacitor analyzer, especially the power supply. Try to understand what we're looking at. So up to now in this video, we were looking at voltage across these C16 and C17, which are two sections of this can electrolytic, which is floated above ground off this V5 regulator tube. So as you recall, I'm getting something like 450 volts between these two and these two. 450 volt rated capacitors. That does concern me. My AC on my meter when I was placing it across here was pretty much freaking out, but when I hooked a scope up to it, I can't find any cause for that. There's no like spikes or something else funny happening here. So this thing hums pretty loudly, and if you feel it after it's been around, these two transformers are pretty warm. This one over here seems hotter than this one. Kind of wondering about this regulator tube. Is that working properly? Obviously, then we have these other two regulator tubes. So next thing I'm going to do is I'm going to check the voltage across this tube to see if that's within spec. Alright, so I pulled up the data sheet for this tube, which is a what is it here? It's a 02B tube. And if you look here, it says there should be somewhere around 108 volts across that tube. And the other thing you'll note is they're showing this, that I think this is, at least if this is normal, we should have a positive voltage on this terminal relative to that terminal. So if we go back to our schematic, this is inverted. So that indicates if both those things are true, then this point should be below ground, which should be like the chassis ground right here. So what I'm going to do next is we'll cut back to the unit and we'll see what the voltage is across this, and if that looks like it's okay or not, and then we'll move on. As you recall, there wasn't a lot of ripple relative to the DC level across these two caps. I don't think they are bad in that regard, because if those were open circuit or quite reduced capacitance, there'd be a huge ripple current or ripple voltage here, and we're really not seeing that. I don't know what's the hum that we hear in the audio has to be coming off these transformers. And in my prior video, you may recall that this thing was pulling around 60 watts, and elsewhere in that manual it says that you need at least a 50 watt isolation transformer if you were using an isolation transformer. So the fact that this is pulling 60 watts and they say you need at least a 50, it leads me to think that it probably is supposed to be pulling somewhere 50 or maybe a little less, you know. So there's, you know, something's drawing a little more current, and I kind of wonder about this T2 because it seems to be hotter than T3. So T3 here, if you look at this, power comes in, goes through your switch, primary or transformer, goes through, you know, a part of the winding of T2 and then back. I'm not sure what's going on with this one. Looking at the layout of the chassis, 6 feet C15 is actually that big, looks like an AC start capacitor, and we'll show that here in a moment. And I'm kind of wondering about that one. You know, if that was bad, it might be loading down T2. Because the other thing is, you notice that these two wires here, they go up to this other smaller transformer, which is part of the bridge circuit that measures the capacitance, and then this stuff over here is an amplifier, and this is your I tube, which in a prior video we see that doesn't seem to be working correctly. So one wonders if there's just something messed up with what's going up to here, or is it the power, you know, coming from these things here going up the bias, these tubes, isn't correct. At any rate, I'm going to go cut back to, we'll look at V5 to start with, and then see what voltages we got across V3 and V4 to see whether they always look normal or not. Alright, we're back, and we're going to take a look across these regulator tubes to see if those are normal. You may recall we just looked at the schematic, and there's a regulator tube between chassis and the negative of these filter caps here, and it looks like it's upside down, so we'd expect to see a negative voltage between that ground point of the cap and the chassis. So I have my meter connected here over at the chassis, so we're gonna touch where I've got my scope probe connected to the negative of that cap. So let's just go right here, and what's our meter saying? We got a negative 107 volts, and that data sheet was showing this should be somewhere around 108. So this negative 107 seems like it's normal and okay, so that seems all right. The other two regulator tubes are these ones up here. So which one is the one we were just looking at? Let's see here. So that's the ground there. That's going up. I don't. Which one is which? I don't know. let's look at this spot right here. We have 255 volts there. I have 106 there. 0 there. 0 there. That spot's common to the transformer. Negative 107. This almost seems like it's the same. Oops. The same reference point. Yeah, I'm not following that wire. Well, actually, it does look like. We follow this spot here, there. It looks like it's going to also that capacitor floating ground. Negative 107. Okay. So this is the floating ground on that one transformer. It goes up here. So then the other, oops, careful here. You got to be very careful. So negative 107 there. That's a regulated tube there. That's 0 volts. This is 0 volts. I'll have to look at the schematic again. So there's positive 107 there. Alright. The thing that I get suspicious about is, it seems to me that this lower transformer might be the source of the hum. And when I had this out, if you feel the hotness of this, these are hotter than I would expect, but the one on the bottom is even hotter than the one on the top. And then we have this, what looks like a motor start capacitor, or some kind of oil filled part here. Starting to get a little suspicious of that, because it seems like these regulator tubes might be alright. I'm a little uncertain about these two. Maybe we need to figure out where we should ground our meter. So this one is the negative 107, so that's like our floating ground. If I ground my meter here, hopefully don't touch anything inadvertently. It's a little scary sometimes. So let's look at that spot. So that's like a plus 107. This would be the same plus 107, so that's 213. We'll look at a schematic to see what we're looking at here. Oops, I keep covering up what I'm looking at with my hand. Alright. We'll look back at the schematic, see if this makes any kind of sense. But my initial thought had been that if these filters are bad or the regulator tubes are bad, we could have some problems, but it maybe not be. That might not be that what the problem is. Alright, well, we'll look back at the schematic for a moment. Alright, we're looking back at the schematic, and we just measured voltage across V5, and it looks like we're getting the expected negative 108-ish volts relative to chassis here. Then we tried looking at V3 and V4. So V3, V4, back up here a second. V3 and V4. So V3 is a 0A2, whereas 4 and 5 are 0A2 or 0B2s. And the 0A2 is a higher voltage drop than the 0B2. So if we look at a 0A2, that one should be somewhere around 150-ish volts, whereas the 0A to, or the 0B to was 108. So if we're back here, we should have on this V3, let's recall what V3 was. V3 was the 0A2, so that's the 150 volt one. So there's like 150 volts here, and there's maybe 108 volts there. So let's just go back and verify that and see if we're getting the right values across each of these relative to chassis ground. Alright, we're back again, and we're going to look at these two bias voltages to see whether they're correct or not. So I've got my meter reference to the chassis ground over here, and we're going to look at these two tubes up here to see whether we got the right bias voltage. Let's try this node here. I don't know what the pinout is. We don't have any voltage there, so it might be the other one. So recall we're expecting about a negative 108 on one of them, although this is negative. We'll have to refer back to the schematic to see the polarity. And then go up to that one, and then let's look at the other one. And that one is plus 106. So do we have a split ground here? So there's 106 here, and there's a minus 107 on that one. I mean, it looked from the schematic that these things are kind of stacked. So that's a little unusual, I thought. Unless I've got these confused. We have a 470K here between the two nodes of this other regulator tube, and then this spot here coming off our this is 318 volts. The chassis is 254 volts, and then we got 106 volts there. We need to look at our schematic again to follow this through to see what we're looking at here. Alright, I took a look at the schematic and I made an effort to redraw it in a little bit easier to read format. So what we want to do is we should see after this 2.2K there should be about 265 volts, give or take, around that spot. And then of course this spot on this V4 should be 108 because of which these two kind of tubes. We got this one, it's about 108, this one's about 150 according to the data sheet. So let's take a look at that. Alright, so the first thing we're going to do is just look at after the 2.2K here. And if we're looking up here, this is that spot right here after this 2.2K right here. So if we look at that, we got 255 volts, which isn't out of the unreasonable from an expected value of about 265, give or take. These things are not precise. Alright, so if we go back up here, on the other side of that 470, I should get about 108 there. So if you look right there, we have 106. So that seems normal. It seems all right. So it seems like these regulator tubes are working. I still don't understand that crazy AC stuff, but it doesn't look like there's anything grossly wrong. I don't like that very high 450 volts across those filters when they're only rated at 450. That could be normal by design. I don't like how hot these transformers are getting, especially the one in the bottom. And then of course our eye tube doesn't seem to be measuring any capacitance at all. Doesn't seem to be working. And if you look at the schematic again, as we were doing earlier, it kind of folds back into, what about this oil-filled motor start type cap that's across that transformer that seems to be hotter than normal? You know, my personal experience with these kind of caps, I had an old air conditioner that was drawing huge currents and melting the power cord and popped a breaker at one point. And the root cause was an oil-filled cap like that on the fan or the compressor motor that went open circuit. So I'm kind of wondering about that thing, and we'll see if we can figure out some way to check that out in case that is the problem with this thing. So I thought I'd check some of the tubes on this thing. So right now I have the 6X4 rectifier tube in the old Sencor Mighty Mite tube tester. So looking at the chart here, we got 6B5A3, so I think I got 6 on the switch, B, 5, A, and then it's in socket number 3. So what we're going to check is, we start with the emission test. I haven't used this tester for a while, so hopefully there's no problems with it. Some years ago I put a new capacitor in it. This was a almost NOS, as an old stock tester I got from some guy 30 years ago, and it belonged to his dad, and I even have the original box for it. I don't think it's been used very much. It's from the 60s. Alright, so we have emissions, looks good. And I don't know about these other tests. Grid leakage. Grid leakage. What's this mean? Jumping around in the question mark area. Not sure what that means. So we got the shorts test, and I thought there's an eon bulb here for that one. And all right. So then there's two sections of this 6A4. So the other one is A and this one's D. So we got A. I'm going to switch to D. Alright, so that one looks good as well for emissions. We go back to this grid leakage, which says bad. Alright. Not sure what that means on a rectifier tube. Grid leakage. There's no grid, right? So alright. Any commentators are free to offer advice here. I'm not a tube man. Tubes were pretty much a non-thing by the time I was taking engineering courses in the 80s. So I mean, I know a few things about them, but I'm by no means any kind of expert. Let's see, short test, nothing much there. It's grid leakage. Now it seems like it's alright. Emissions, definitely emissions are good. Go back to A. Emissions are good. Maybe the grid leakage is alright now, huh? Shorts test. Is that good or not good? Definitely a fairly hot, smoky tube right there for sure. I guess I don't think there's anything, the reason to think this one's bad. This, especially the shorts test. I thought that this neon bulb here, if it was a shorted tube, is supposed to glow if there's a short. So, alright, seems like the 6X4 rectifier tube may be okay. I mean, it seemed like it was working in the application. In other words, it looked like it was rectifying. We had DC voltage there. Not an excessive amount of ripple. Alright. On to the next thing. Alright, I've been testing the tubes in the capacitor analyzer, and this is the last one, which is a 12AT7. So I think I have, per the chart, all my switches set, and we're going to turn this one on. They've all been okay up till now. Alright, so as the tube warms up, we are in emissions test, so that looks good. We go to grid leakage. Grid leakage looks good. Next we go to the shorts test, and there's no glowing neon bulb there. So okay, so then the 12AT7, I think that has two sections in it. So the other one we want to switch to switch B goes from B to E. Switch D goes from B to E. So that's this one over here. Go to E. Shorts test is still okay. Grid leakage is still okay. Emissions is still good. Alright, so this has been all the tubes that I can test. I can't test the gas regulator tubes. This tester will not do those. But earlier we looked at the voltages across them, and they looked alright. So I don't think there's any problem with the tubes in this piece of equipment, this capacitor analyzer. And we need to look at a few other things. Alright. So I had some suspicions about this oil-filled, or what I think is oil-filled AC capacitor across one of the windings of the transformer that I think is hotter than the other one. Alright, so I've unsoldered the wire on one end of it, and we're going to use the capacitance test on my DMM to check the capacitance across this thing. If you recall from this, well, from the parts list, it's a 1 microfarad part at 660 volts AC. Alright, so we're gonna set that at capacitance, and we have our other end connected to one terminal. The other one's completely open, so we're gonna hook that up and see what we get. So this is showing 1.1 microfarad, so that would be okay. You know, it's within expected. Definitely not open if it's measuring something. Let's change to resistance and try this again. And we have well into the megohms here, so that cap is as you can see, it's increasing, so it tells me it's not initially open. And the fact that it measured an expected relative level of capacitance says odds are this cap is okay. So that's not a root cause of our problem. Why perhaps this transformer is running hot. You know, I don't know if this is normal for this device. Maybe these do run hot. Certainly there's a problem somewhere where the bridge for the null indicator I tube isn't working properly. So maybe the problem really is there, and even though this thing hums and gets hot, maybe that's normal for it. Short of someone else chiming in on these videos telling me that, oh yeah, that's a problem or not a problem, I'm not really sure. Alright, I think I'll call this video for the time being and resume on this at some other time. Looks like I need to investigate a few more possible problems with maybe bad capacitors or something else. The other thing I should do is, assuming the power supplies are working properly, from looking at the schematic, it seems like the capacitance measurement portion is separated from the DC bias and leakage and resistance test part. So my earlier video, maybe I just wasn't setting it up correctly for those DC voltages. On the other hand, the AC bridge measurement for the capacitor, there definitely seems to be a problem there. So maybe there'll be a part 3 on this in some future time. All right, all for now.